Welcome to Nolte Chapter 16, the thalamus and internal capsule. So getting to and from the cerebral cortex. The diencephalon includes the thalamus and hypothalamus. So that is our primary and secondary vesicles again. Primary, prom-rom, prosencephalon, mesencephalon, rhombencephalon. And then remember, mesencephalon does not differentiate out. It is one of the 5 secondary vesicles as well. So tel, di, mesmet, mi. So diencephalon is all things that have that root of thalamus in there. Nice picture for you here, so you can see the thalamus in that center purple circle is the thalamus, and then the inside there is that interthalamic adhesion that's connecting the 2 hemispheres of the thalamus, thalami. And a nice picture here for you as well. So we have our cord, medulla, pons, midbrain, and then jump up to where that thalamus is, and then you can see that interthalamic adhesion right here is thalamus. Remember, it is bilateral, egg-shaped nuclei, so there's a right and a left aspect to the thalamus, just like for your cerebral cortex. So it makes up 80% of the diencephalon. And another picture here, side view of it, so it's that purple structure at the top. Thalamus, it's the switching station, so information is coming into this area, and then the thalamus sends it out to the appropriate area in the cortex. So think about homunculus man for sensation and also for motor, but motor's not going through here. Okay, so just sensation. Main thalamic function to act as a relay station for information coming in. So sorts, edits, and relays ascending input, such as impulses from the hypothalamus for regulating emotional and visceral function, impulses from cerebellum and basal nuclei to help direct motor cortices, impulses for memory or sensory integration, and overall it acts to mediate sensation, motor activities, cortical arousal, learning, and memory. Pretty subtle, this slide here, so make sure that you memorize this. This shows up on your test, so take some time with this one and make sure you know what these structures are. Here we can see the blue thalamus, and then just below that the corpora quadrigemina, or the superior and inferior colliculi. You can see the lateral geniculate bodies on that thalamus and the pulvinar. Okay, so take some time with this one. Side view for you. Another view. Feel free to pause at any time that you need to take a little more time to look at these structures. There we go. Same stuff. Diencephalon has 4 parts: epithalamus, which includes the pineal gland, dorsal thalamus, subthalamus, and hypothalamus. Go ahead and read this. It talks about the pineal gland. Thalamus is the gateway into the cerebral cortex. Again, we call it the grand central station, or the switching station for processing sensory information. It's a relay information from the periphery receptors, basal ganglia or nucleus, and cerebellum to the cortex. Cortex also sends some fibers back and says, hey, I got it. And then you can see the corona radiata, so there's crown radiating out from it. That's what that picture is. A couple other viewpoints of the corona radiata, so you can get an idea of what that looks like. Internal capsule, so that surrounding area from the thalamus. So if you look to the purpley blue thalamus area, and then if you look here, let me get my pen. It's been inked here already in red, yellow, and blue, that internal capsule. So anterior limb between the head of the caudate and the lentiform nucleus. And we're going to see thalamocortical tracts. The genu is the bend or the knee, transition from anterior to posterior limb, a level of interventricular foramen, and we see cortical bulbar tract here. Posterior limb. So make sure you know this is where the cortical spinal tract is. Posterior limb, cortical spinal tract. So between lentiform nucleus and the thalamus, optic radiations and auditory radiations, and most importantly, the cortical spinal tract is what we want to remember. are different thalamic nuclei. Intermedullary lamina, we're going to see white matter here, separates anterior, medial, and lateral nuclei. So you can see that white line running through the thalamus there. Interlaminar nuclei lie within the internal medullary lamina, connections with basal ganglia and almost every part of the cortex. Cortical activation and sensory motor integration. Midline nuclei considered part of the limbic system. Remember, limbic system is going to be all things emotions. Play a part in memory and alertness. Thalamic reticular nucleus is just lateral to the thalamus here, so separating the thalamus from the posterior limb of the internal capsule. It's the gateway for flow of information between thalamus and cortex. Anterior nuclei, so our hippocampus, anterior limbic area, cingulate gyrus, and parahippocampal area. So a lot of things that have to do with emotions there. Regulate alertness and attention and acquiring memories. Our medial nuclei are our primary olfactory cortex, amygdala. Remember, amygdala is like anxiety, fear, things like that. Prefrontal cortex, emotions and higher cortical thought. Lateral nuclei, dorsal tier, vision and temporal, parietal. Lateral dorsal nucleus, lateral posterior nucleus, the pulvinars, posterior, remember. Ventral tier, primary cortices, being ventral anterior, ventral lateral, ventral posterior, lateral medial, and then our lateral geniculate body and medial geniculate body. So lateral geniculate body we associate with sight, medial geniculate body we associate with hearing. VPL, ventral posterior lateral, so remember that's that spinal thalamic pathway and dorsal columns. So both spinal thalamic and dorsal columns will travel through the medial lemniscus and then go up to that VPL and then out to its appropriate area of homunculus man in the cortices. VPM is for trigeminal, okay, so trigeminal thalamic pathway. Lateral geniculate visual, medial geniculate auditory. So VPL, spinal thalamic dorsal columns, VPM, trigeminal, lateral geniculate visual, medial geniculate auditory. Here's a nice picture for you. I like to use this one on the tests. I think it's an easy one to decipher here. There are reciprocal connections. So if thalamus sends out a message to the cortex, it will receive a message back. So it's kind of like saying like, okay, copy, I get it, I understand it. And this is talking about the mammillothalamic tract, so mammillary bodies, anterior nucleus of the thalamus receiving limbic info and projecting into that cingulate gyrus of the limbic lobe. And then VPL, VPM, geniculate nuclei, and motor and limbic also have thalamic relays. Another neat picture here kind of pulls it all together, so feel free to pause here and check that one out. Internal capsule, so white matter projection fibers between caudate and thalamus medially, and lentiform nucleus laterally. You can see a nice picture of it there as well. Internal capsule has 5 parts that we want to remember. Anterior limb connecting anterior nucleus, cingulate gyrus. Posterior limb for VAL, VL to motor cortex, so that's ventral, anterior, ventral, lateral. Genu, or the bend, or the knee, that's the transition zone between anterior and posterior. Retrolenticular part, so when you see lenticular, think like basal nucleus. Okay? So retrolenticular part, so behind the basal nucleus. Thalamus to cerebral hemisphere connections, optic radiations here. Sublenticular part, optic radiations. And here is a pretty neat picture. Go ahead and pause it there if you like. And there you go. The end of this chapter. I will see you in the next chapter.